this is a continuation from the 9-2 video with our trig addition and subtraction identities for sine and cosine. So I'm going to take a look at the problems involving proofs for our identities. So the first example that I'm going to take a look at is one where they're asking us to first determine if it's a possible identity, and if it is, to prove it. So for these problems, whenever we're being asked the question to determine if it's a possible identity, we're going to our graphing calculator and referring to the graphs. If the graphs of them appear to be the same, then we're going to say it's a possible identity and try to prove it. If they are not the same, then we say that it is not an identity. So we are looking at trying to prove 2 cosine x sine y is equal to sine of x plus y minus sine of x minus y. So to first determine if this is an identity, I'm going to take each side and graph it. So under y1, I'll type in 2 cosine x sine, we can't enter y there. So we can only, on our graphing calculators, it's only a single variable, so we can only input one unknown on this side. So in order to determine if this is an identity or a possible identity, we're going to choose a value for y. You can choose any value for y in terms of radians, in terms of, it doesn't have to be in terms of radians. So for example, I'm just going to pick y equals 1, just because it's easy to type in. And if, when I plug in that value for 1, if these come out to be the same, then the chances are that that's an identity. However, if when I type in 1 they're not the same, then there's no possible way that those are an identity. So instead of entering the y there or another x, I'm going to just enter 1. And if I enter 1 here, I have to enter it over here as well. So then also I'll do sine of x plus 1 minus sine of x minus 1. And again, that's just going to give us an idea if it's a possible identity, and then we'll try to prove it. There are very few switch situations where you might input a value and it comes up to be the same. However, it's not always the same, but for most of the problems we're dealing with, it's not going to be that tricky. So I'm going to input y1, 2 cosine x sine of 1, and under y2, sine of x plus 1, minus, just that parenthesis, minus sine of x minus 1. And again, I have the second line on bold so that I can differentiate between the two graphs after they're done. And there is the 2 cosine x sine y, and then here comes our sine of x plus y minus sine x minus y. So therefore, based on what we've seen, this is a possible identity. So then I'm going to try to prove it. So on the left side, I have 2 cosine x sine y, and on the right side, I have sine of x plus y minus sine of x minus y. These proofs are actually, some of them can be a little bit easier because your input step is just inputting these addition and subtraction identities for sine. So I'll have the addition identity for sine, sine x cosine y plus cosine x sine y, and again on the skill check and on the quest next week, I'll provide those for you, those identities. You just have to know how to use them. Now be careful on the second one, we're then subtracting the subtraction identity. So it's minus sine x cosine y minus sine x, cosine x. I have that wrong up there. all getting muddled together. So then again, the thing to be careful about down here is the fact that we're subtracting this piece. So it becomes sine x cosine y plus cosine x sine y minus sine x cosine y, and then plus, because subtracting the minus, cosine x sine y. So then, going through my terms, sine x cosine y minus sine x cosine y. So then it's just cosine x sine y plus cosine x sine y. It's the same thing. So there's two of them, 2 cosine x sine y, which is what we wanted to have come out. So 2 cosine x sine y. And that is the proof for that identity. I'm going to go ahead and look at a second proof has a little bit more going on that is going to be related to the second round of proofs in the homework. So cosine of x minus y all over cosine of x plus y is equal to the cotangent of y plus tangent of x all over cotangent of y minus tangent of x. So most of my work that I'm going to do is going to be over here on the left side, because I'm going to have fractions within the fraction that can go ahead and be simplified. I'm going to, though, go ahead and write down my subtraction identities in this side of the fraction. So it is cosine x cosine y plus sine x sine y for the subtraction identity for cosine, all over cosine x cosine y, and we switch that sign, minus sine x sine y for the addition identity of cosine. On this side, I'm going to rewrite my tangent and cotangent in terms of sine and cosine. So it's cosine y all over sine y plus sine x all over cosine x all over cosine y sine y minus sine x over cosine x. So I've been doing a lot of problems with doing cross multiplication. This problem could also be done and proven to be true using cross multiplication. So you'd be multiplying this binomial times this binomial, and you'd be multiplying this binomial times this binomial. And you should end up in that process with ending the same thing on the left and the right. However, I thought it would do it justice by doing something maybe a little bit different this time. So what I'm going to do this time is actually just working on the top and the bottom of this complex fraction. I'm going to get a common denominator and combine these two fractions, and also do something similar down here and get a common denominator and combine these two fractions. Once I have one fraction divided by another, I can use the idea that I could then multiply by the reciprocal of the one at the bottom. You cannot do that when you have two fractions in here. You have to first combine them, then multiply by the reciprocal. So just looking at just the top, I'm going to get a common denominator of sine y cosine x. So just looking at the top, sine y cosine x. To make this fraction have that sine y cosine x denominator, I have to multiply both the top and the bottom of it by cosine x. You might start to see how this is going to work out. Cosine x cosine y, cosine x cosine y, plus, on this piece of the fraction, again, I'm getting this to be my common denominator, sine y cosine x. So I need to multiply by a sine y on the top and the bottom of that piece. So sine x, sine y. And again, we're all over sine y cosine x. Could have just put that all together in one to begin with. And then, it's really the same thing in the bottom. Cosine y, sine y, cosine y, sine y. The difference is the top has an addition and the bottom has subtraction. So I'm just really going to write the same thing. With a subtraction sign in between. It's tempting to want to just cross these things off and do like this type of thing, but you can't. Remember that we can only reduce things that are factors. This and this are not factors of the top and the bottom. However, I am going to go ahead and combine this, cosine x cosine y plus sine x sine y, all over sine y cosine x, and combine the bottom, cosine x cosine y minus sine x sine y. Again, I kind of took a extra step here that was not really needed. Could have gone just straight from here to here, knowing that I was getting a common denominator in order to combine these. So now, once you have one fraction divided by one fraction, now you can use the idea that means multiplying by the reciprocal. So I'm going to take the top of the big fraction, the complex fraction, and multiply it by the reciprocal of this bottom fraction. Minus sine x, sine y. I keep losing track. I'm always afraid that I'm not going to be able to do that. And these two pieces will reduce, and we're left with cosine x cosine y plus sine x sine y all over cosine x cosine y minus sine x sine y, which is exactly where we needed to end up. They're the same thing. Notice also, not notice, but maybe take note, we have to have this final step to show that they are the same. So again, that was going through the process of simplifying this complex fraction that was on the left side. Again, a lot of the other identities that I did in 9-1, I kept cross multiplying. It's like I got stuck in the rut of cross multiplying. Technically, again, you could do the same thing with this one. You'd have a lot of reducing, and you would still end up with having the same thing on the left and the right side. As long as you get there, don't make any illegal steps. I'm fine with a lot of different methods, and if you're ever not sure, just ask. As I was talking about that one, I did want to go back and just remind you about example 3. One thing to note here. So I did in this process, when I plugged in the 1, I used that in the graphing calculator. However, when I went back to do the proof, I left in the y. Don't put in the 1 in the proof. The 1 or the whatever other number that you plug in is just to see if it's an identity. And then for the proof, you use both the variables. Okay. So again, those are a couple examples to try to guide you along your way for the second half of that 9-2 homework, which again is due on tomorrow, Tuesday, and we'll be skill checking on Wednesday. Have fun, my dears.